Today we'll be looking at tensions in cables. So tensions in cables are divided into two. The first one is catenary, then the second one is suspension bridges. So for the formulas, I will be using this textbook, just for the formulas only. Then the questions that I'm going to be doing on this topic, that are going to be based on this one. So starting with the catenary cables. So we are going to be having two. We are going to be having, the first one is going to be when the two poles are on the same level and they are equal in height. And the second one is for when the two poles, they are different in height. So let's first look at the one where the poles are equal. So let's say we have pole A and pole B. This is the ground. This is the ground. So we are going to be having a cable here, and the cable is going to sag like that. So the sag is going to be called UD. So the sag, you will always measure the sag from the shortest support or a pole. So from the shortest support, that's where you are going to be measuring your sag from. Then we also have the length of the cable from this support to that support. So here, this is going to be the center here. So here, the distance, let's call our center O. There at the center, we are having point O, which is the turning point of the cable. So the distance from the ground to there, let's call it YO, and the distance from the ground to there, or the height of this support, let's call it YB, and the height of the support, let's call it YA. Then the distance now, or the length of the cable from point O to support B, let's call it LOB, and then the distance from this support to there, let's call it LOA. So meaning that the total length of the cable is going to be equals to LOA plus LOB. Then there are forces that are acting on our support as well as in the cable. So when the question says calculate the minimum tension, let's name the forces first. So we are having FH. FH is our minimum tension. Then we are having FV being our vertical tension. Then the last one is called FT. FT is going to be our maximum tension. So when they say calculate the minimum tension, they mean calculate FH. When they say calculate the vertical tension, you calculate to FV. When they say calculate the maximum tension, you will calculate value or FT. So now the question is going to say, calculate the tension in the cable. You see, it's not specific to say calculate maximum or minimum tension, but they are saying calculate the tension in the cable. Once they say in the cable, whether you are going to calculate FH. And if they say calculate the tension at the support, whether you are going to calculate FT. So FT is the tension at the support and FH is the tension in the cable. Now, you are going to pause this video so that you can get these formulas, or you can screenshot the formulas. Right. So, as you can see, this side is the same, is similar to this side, and they're equal, they're the same, right? So, when you are calculating for a question like this one, where the supports are of the same level, what you can do, you can simply just focus on one section, then you simply just multiply your answer by 2. You see. So, let's take one question and see. On our textbooks, this one, we are going to go to page 58. So on page 58, I'm going to look at number 1, 2, 3, as well as maybe number 5. We'll see. Okay. So, starting with number 1. It says, a cable with a weight of 29 Newton meters is suspended between 2 supports on the same level. So these 2 supports, they are of the same level. The distance between the supports is 80 meters. And the sag of the cable is 8 meters. The length of the cable is 82.1 meters. Calculate what we're doing, the maximum tension in the cable. You see, but it did say maximum tension. So remember, I said to you, if they say calculate the tension in the cable, but they are not specific to say maximum or minimum. When if they say calculate the tension in the cable, when you calculate FH. But this one is saying to you calculate the maximum tension in the cable. So that is what? That is FT. So we are having this one. So on this one, we are given the length of the cable from here all the way to there. We'll say it is 82.1. So when you say 82.1 divided by 2, you get 41.05. So meaning that the distance or the length of the cable from here to there, it is equals to 41.05. Also, you are given the sag D. You will see it is equals to 8. Then you are also given the distance between the supports. We are given the distance between the supports. The distance from here to there. We will see it is what? It is 80. So meaning that the distance from here to there is going to be equals to 40. So the distance from here to there, we are going to call it a capital letter L, like that. Then small letter L will be for the length of the cable. Capital letter L is the distance between the supports. Then small letter L is the length of the cable. So the length of the cable, because it is sagging, it is not going to be equal to the distance between This one is curving, this one is straight. So these two lengths, they are not going to be equal. So now we want to find what? The maximum tension in the cable. Then we go to our formulas. On our formulas, we see that the maximum tension in the cable, Ft is equals to WYB. So if Ft is equals to WYB, let's see. We are given W, it is what? It is 29. We want to Ft, so the only thing that we are left to figure out is what? Is OYB. So how can we find OYB? Now, what else do we know? We know what's in YB is going to be equals to YO plus OD there. So it's going to be equals to YO plus OD. And we have OD, we have OD. So we need to find YO. So how can we find YO now? So from our triangle of forces, we said what? This is what we said. It tells us what here we are having OFT, here we are having OFV, here we are having OFH, like that. Right? So, meaning that I can also do this. What do I know about OFV? I know what OFV, it is equals to 1. My LV is equals to WLOB, so meaning that this side I can put LOB. Then this side FT, we said FT is equals to WYB. Then here we can put YB. Then here OFH is equals to WYO, so meaning that here we can put YO. Right? So on number 1, we are not given what? The angle of the cable, right? If we were given the angle of the cable, it would have been easy because we do have one LOB, but we do not have the angle of the cable. So what can we do then in that instance? It means that now we can use Pythagorean theorem. So YB squared is going to be equals to YO squared plus LOB squared. Right. So from this one, let's solve for YO. So if we are going to solve for YO here, we have solved for YB there, right? So we know this where there is YB, I can substitute with that. So it's going to be YO plus OD. Squared, this is going to be equals to YO plus LOB. LOB is equal to 41,05. Then YO plus 8. So we said it's a difference of 2 squares, so it has to be YO squared plus 16 YO plus 8 squared, which is 64. And this is going to be equals to YO squared plus 41 squared is equal to 1621, 1025. Yeah. Then from here, we can take this one to that side. And also take a number that will vanish. And we left with 16. 16 YO is going to be equals to minus 64. 16, 21, Here we are having O, Y, O much. Once you have Y, O dot D, you get Y, Y, E. So this is now going to be equals to 101, 319, plus 8. So this is going to be 109, meters. Now that we have YB, we can now find UFT. So this is going to be equals to, we have 129 multiplied by 109, divided by 9. So 29 multiplied by 109, you get 3170,25251 newtons. There. This is our what? Our FT. Then the second question says calculate the minimum tension in the cable FH. FH, we said that FH is going to be equal to what? W what? WYO1. And our W is like O1, O29, YO to O1, 109. You see, once you solve for YO, everything is now simple. Then here, we are going to find FH. YO is 101, 319. We get 29, 38, 251. There. We have O1, FT, we also have FH. The last question is saying calculate the maximum slope of the cable. So for the slope of the cable, you can use any of these. We want this angle here, the slope of the cable. It is that angle. So it takes you back to your trigonometric ratios. So control like that. So you have YO, you have LOB, you have YB. So you can find anything that you want. You can find that angle. Also, you have FH, you have FT. You can find that angle there. So any, we are going to give you the same answer. So let's see, cos theta is going to be equals to my adjacent, which is FH 2938,251 and this divided by my hypotenuse, which is FT 3170,251. You are getting theta degrees. Then there is number 2 there. A chain with the length of 32 meters is suspended between 2 points on the same level. The angle of the chain with the horizontal at the support is 60 degrees. So we are still having supports that are of the same level. We are still having supports that are of the same level, and we are told that the length, a chain with a length of 32 meters. We are given the length of the chain, which is 32. So 32 divided by 2 is 16. So LOB is now going to be equals to 16. The angle of the chain with the horizontal is 60 degrees. The angle of the chain with the horizontal, here it is equals to 60 degrees. Then calculate the sag of the chain. This one is what? 60 degrees. On the LOB, which is 16, you have the angle in 60 degrees. Ufuna bani? Sifuna the sag of the chain. What do we know? We know what YB is equals to YO plus bani plus UD. So, ukuze sikhole ukuthola UD, sidinga YB as well as YO. And if I have LOB, I can solve using the trigonometric ratios. I can solve for YO as well as YB. So, if I'm to solve, this is my opposite. I want my YO, which is the adjacent. Opposite and adjacent, that is tan. So, tan 60 is going to be equals to my opposite, which is 60, all this divided by my adjacent, which is YO. Then here I'm going to find YO over me. 16 divided by tan 60. I'm getting my O to 9,23238 meters. Then after that I solve for YB. Then YB is going this one is a hypotenuse and an opposite. Opposite is the hypotenuse. That is sine. Sine 60 is going to be equal to my opposite, which is 60, or this divided by YB. Then my YB is going to be equal to 16 divided by sin 6. You will get to YB, which is equals to 18,475 meters. Then now that we have YB, we also have here again. So below D, YB is equals to 18,475. This is going to be equals to YO, which is 9,238 plus D. Then we minus we told it DY. 18,475 minus 9,238. We can do D is 9,237 meters. Then the second question, 2.2, is saying calculate the distance between the support. X1 is going to be equals to YO of YB plus what? Plus LOB, all this divided by YO. Then we said that YO is equals to 9,238 enough our YB, which is 18,475 plus 16 on this divided by 9,238. simply just multiply your answer now, not to one. So n is now going to be equal to 12,166 multiplied by 2. Multiplied by 2, you get 24,331 meters. Then the third question is saying a cable is now suspended between two supports, and support P is 6 meters longer than support Q. The side of the cable is 5 meters below the top and the shorter support. The weight of the cable is 8 Newton meters. The minimum tension in the cable is 200 newtons. Calculate 3.1 the maximum and minimum tensions at the support. So we want to find these two now. These two supports, they are now no longer equal. We have two supports. Support P is 6 meters long, so the longest one is P and the shorter one is Q, right? Then we have the sag, which is D, and then we have this height here, H. Then we have this one here, YO. And we should remember the turning point, then we are saying that it is O. Okay, then we have this one as our L, then this one is going to be XP, then this one is going to be XQ. So meaning that L is equal to XQ plus XP. Then they say calculate the maximum and minimum tensions at the support. You see, you can, if you are starting to analyze this, you can easily make a mistake here. They say calculate the maximum and minimum tension. Yeah, so you would think that they want you to calculate FT and FH. It's true, yes, they want you to calculate FT, but not FH. Why? They said at the support. You see, so we want to find, remember, this support and this support, they are now no longer equal. So it means that the FT, the maximum tension of this support, is not going to be equal to the maximum tension of this support. You see, this one, it has more cable, meaning that it is carrying more weight than this one. So meaning that this one will be experiencing more tension. So here we are going to be having this side the maximum tension, and then this side we are going to be having minimum tension. But both of them, they are still what? FT, because we are talking about the support. So you have the smallest FT here, FT mean, then this side we are going to be having FT max. That's what I'm trying to say. You still have minimum tension in the cable, yes, but now we are simply just talking about the minimum tension at the support and the maximum tension at the support. So, what do we need? Here we are having running YP, and then this side we are having YQ. YQ is going to be equal to YO plus plus B, right? And YP is going to be equals to YO plus D plus OH. This distance plus that distance plus that distance, it gives you that. But this one and that one, it gives you that. So, looking at this one, we are given what on the statement? We are given the side that it is 5. We are also given the height h. Let's say it is 6 meter long and 6. So we do not have OYO. Fine. So let's see if we can find OYO. I remember somewhere they said minimum tension in the cable is something. Let's see. The minimum tension in the cable is 200 Newton. You are given FH. So what do you know? You know what FH is equals to WYO, right? So W bottom value is 8. So this is going to be 200 is going to be equals to 8 multiplied by YO. So what is 200 divided by 8? You get 25. So YO is equals to 25. So here plus 25 plus 5 plus 6. We find what? We find 36. So we learn 25 plus 5. Here we are going to get 8 meters. So now that we have YP, no YQ, we can now calculate the tensions that we want. So FT is going to be equals to WYQ as well as FT is going to be equals to WYP. So this side is going to be equals to 8 multiplied by 30. And then this side you are going to get 8 multiplied by 36. So 8 multiplied by 30, you get 240. Newtons. And this side, 8 multiplied by 36, you get 288 newtons. Then the second question is saying calculate what? The length of the cable. So we are going to calculate by the length of the cable. So you still remember this. YO, YP. This one is for YP. Then let's draw another one for YQ. So we want to find the LOQ or LOP. We have Y over YP as well as Y over YQ. So once we find these two, we simply just add them, then we check. So YP squared is going to be equals to LOP is 12 over 36. So this is going to be 36 squared minus y0 is still 25. 25 squared, then all this is going to give you LOP. Okay, let's turn those to LOP by simple 14. YQ squared is going to be equals to LOQ squared plus y1 squared. YQ is still 30 squared minus 25 squared. This is going to give you LOQ. So the root of 36 squared minus 25 squared gives us 25,904 meters. Then beside LOQ, the root of 30 squared gives us 16,583 meters. Then L is going to be equals to LOP plus LOQ. And here we're getting 25,904 plus 16,583. And here you're getting you'll get 42,487 meters. Third question, slope of the cable. Number one, when the angle, you can tell that again what is. Oh, catenaries are simple. They are not confusing. Actually, nothing is confusing. So, now, I want to find the maximum slope of the cable, right? So we said that sin theta is going to be equals to. Now, here we've got the length. What's over LOP? We got 25 over what? Those were the root of 36 squared minus 25 squared. 25,904. All this divided by YP weight is over 36. So now maybe you might have a question with it. Why are we using 25, not the 16 comma something? So we want the maximum slope of the cable, right? So the maximum slope will be this side. Ne? So therefore theta is going to be equals to Then, fourth question says calculate the distance between the supports. So we have OX cubed, then this side I'm going to do OXP. So the formula says YO in of YQ plus 1 Q, all this divided by O Y O, right? And so this side is Y O in of Y P plus L O P, all this divided by Y O. And this is going to be equals to Y O into C2 1 25. In of what? OYQ into C1 36 plus AOQ C1 25,904. All this divided by 25. That's what's all one XQ. Then this side is still have 25 in of 30 plus. Yes, it's understood about 30 squared squared. So 16, 583. All this divided by 25. So 25 of 36 plus 25,904. All this divided by 25. Here you are going to get 22,668 meters. So dating upper 16 upper 583. And this side you are going to get to 15,559 meters. So we want what? The distance in between L. Like I said, L is equals to x cubed plus x cubed. So L is equals to what? X cubed plus xp. So 22,668 plus note. I did vice versa with the letters, but still the same answers. 15,559. It's just the letters here that I did vice versa. Yeah? So this is just LOP, 1P, and 1XP. Then this side is substituted for Q. Yeah? Q, that's what it's saying. Q, it's just that. But everything else is fine. And then the fifth question now is saying calculate what? The horizontal distance from support P to where the tension in the cable is going to be 260. Remember, when I'm here, the tension here at O is equals to 200, right? Minimum tension at the cable. As I go up, the tension increases. So at some point along the cable there, the tension is going to be over 260. You understand? So let's treat this point. Let's call it point Z for Zulu. So there at point Z, the tension is 260. So that is, let's treat it like our support. Let's say this is a support here. So we want to find the distance, the horizontal distance here. We want to find xz there. So what are we going to do? This is what we are going to do. So with that, we are going to find yz, the length of the support, which is uz. So we are going to say yz is going to be equals to 260 on this divided by 8, which is our w. So meaning that ft is equals to w. It's this formula. ft is equals to w yz. At first it was yp, but now we're on yz. It's this formula here. Okay. So here you are going to 32.5 meters. So now that we have yz, let's see if we can find the distance from here going there. Let's call it xoz, from O to Z. So xoz is going to be equals to yo in of what? In of yz plus loz, all this divided by yo. So we do not have loz, but that doesn't mean we cannot find loz, right? Remember, we have yo is 25, right? So we simply just want that one addition, and we do have yz, go to 32.5. So this, let me make my new triangle. We have yz, go to 32.5. We have yo, go to 25. Till it's loz. So by that one there again, yz squared is going to be equals to yo squared plus loz squared. So yz is 32.5 squared minus yo 25 squared. So the root of this is going to be loz. So loz is going to be equals to what? What is the root of 32.5 squared minus 25 squared? Here you are going to find loz is equals to 20.767 meters. So now you can substitute here. Yo is 25 in of yz, is over 32.5 plus loz 20.767, all this divided by 25. Then here we are going to get getting 18.911 meters. Remember, this one is what? xoz is the distance from here to there. The question to you, it said, calculate the distance from here to here. Right? So what you are going to do right now, and you should remember, we did calculate to xp from 3.4, where they say calculate the distance in between the supports. So what you simply just want to do right now, you will simply just say xp or xz is going to be equals to xp minus minus xoz. So I forgot the exact value. So I'm just going to, let's say 26.6 minus of x or z, which is 18,911. You will rewind the video just to get the exact value of this one. I forgot that value. 26.6 minus 18,911. I erase it here. So we are going to get with the distance is 3,689. This is just mine, remember, because I used 22.6. When you use the 3 decimals, it might differ just here, you see, but it's still going to be 3, something. So yeah, this brings me to the end of today's video. Then next we are going to talk about the suspension bridges, the parabolic catenaries. So after that one we are going to